Hey everyone, welcome back to another exciting episode of Programmer Polyglot, the show where we turn code into creativity and problems into possibilities. I am your host Kalyanasundram K, and today we are diving into something special, a color palette extractor you have built using Python. Imagine being able to upload any image or a photo, a painting, even your favorite wallpaper, and instantly get its most dominant colors displayed as neat, elegant palette. Where you are a developer, a designer, or someone who just loves colors, this tool is super useful. We will break down this entire code into snippets from reading an image with a pillow, like pillow library, clustering colors with KMeans, the algorithm, and finally visualizing it using Matplotlib. And yes, there is a pinch of Tkinter images and magic too for the slick file picker. By the end of this episode, you will not only understand how the color clustering works, but you will have a functional tool that's perfect for the design inspiration, UI theming, or just geeky fun. Let's get into it. Alright, let's start by understanding the magic behind the color palette function. And let me first show you a demo of it. Let me run this code. Now the code is running. Let me wait for some time. Yeah. So this file picker will be selecting a file which we need to give the color palette. Let me choose this file and the color palette will be resulted. So let me show the file now. So this is going to be the file I astronaut with the blue color palette. So let me compare this. Yeah, it's like similar to all the colors that is being focused on approximately. So yes, today we are going to develop this application using Python. Let me start with the code in a new file. What are the things you are going to learn today? That's the first question comes into your mind. I know. So these are the things. How to read and process an image in Python. How to extract dominant colors using KMeans clustering. That's the algorithm we're gonna use now. How to build a simple file selector GUI. How to display the color palette visually with Matplotlib. That's our main question. So let me start with the steps. Step 1. As usual in Python, we are going to import libraries. Let me start with that. Initially, we need to import NumPy, which is for numerical analysis, and followed by pillow library. So not a usual one. It is a library for image analysis and image return in Python, followed by scikit-learn. Thanks to Copilot, and followed by sklearn. Sklearn is a library which is used for machine learning purposes. Today we are going to use KMeans from sklearn library. That's the inbuilt algorithm in sklearn, and followed by Matplotlib for the final deployment. That means the output will be shown in Matplotlib graph. That's the reason we are using Matplotlib. Followed by Tkinter for UI. And followed by system library. System library is just for logging purposes. So let me like reimage all the things. What are the libraries and what for? So pillow is for opening and researching the images. K means for finding dominant colors. Matplotlib for pyplot. That is plotting the palette. Followed by tkinter for GUI selection. System for command line arguments. That is logging. And followed by we can start with the function. So within the function, we are going to extract dominant colors from an image. Let me start with the function. So def extract colors parameters are the image path that is given by the UI dialog of tkinter, and num colors is equal to 5. 5 colors will be selected from the image. So after this image, I'm sorry, we need to assign a variable here. Image equal to image dot open of the image path and convert that into RGB so that the colors will be extracted from it using KMeans. RGB and we are resizing it in 100 pixels. I'm sorry, dot resize 100 comma 100. Yep. Followed by the pixels, so you need to use np array to reshape that. Pixels is equal to np dot array of the image, so image will be passed in this array. I'm sorry, dot reshape of -1, 3. So here we have done with the image. We have get the image using the function in the parameter and open the image and convert it to RGB. Followed by we are passing the image in an array to reshape it. And now the main action comes here. So KMeans, we are declaring the KMeans here. KMeans equal to KMeans of n clusters equal to num of colors. So the colors answer is 5. And n init. These two are the parameters for KMeans, init and the clusters. Followed by it will be auto. And we have got the pixels. We are used KMeans, and the last thing is we need to fit the model. KMeans dot fit of the pixels. And the second thing is we need to count. np dot bin count of KMeans labels. Followed by the indices. We have counted the thing how many pixels and followed by the indices. Indices are the things, the total number of pixels and followed by the count variable. np.argsort minus of counts, so that is going to be the opposite direction. Let me have it as counts. Not a bigger problem, but the reference should be correct. So this function is going to return k-means cluster centers. So this is going to be the 5 things. So we have given the number num colors is equal to 5, so it will be representing 5 colors. Let me start. So first is k-means cluster centers. K-means dot clusters centers, which will be I in iteratable form as soon as all the 5 colors will be returned. Dot as type should be int, and loop goes here for I in indices. Let me recall it what the function does. Load and resize the image to 100 into 100 as we mentioned there, and flatten the image using our RGB pixels, and use k-means to find num colors clusters, sort clusters based on the frequency. Final thing is we are returning the dominant RGB colors. that is 5 colors. So let me start with the file picker. So the file picker is just for selecting the image as you've seen in the initial case of the video. So def select file. Let me start the definition of the function. Root will be always tk.tk, and it is case sensitive, just be careful. Root.withdraw. So initially the root will be a screen, but here we know it, we don't need a screen, we just need a file picker. Make it simple, I've just included the file picker only, not a screen. So root.return, so it will be written it as a file dialog dot ask open file, and you need to mention the file type, which is as usual the images will be in jpg, png and jpeg file or bmp. So you need to mention the file types. Let me have it like image files. I'm sorry, yeah. So first is jpg. Have a separator like star jpg space again star, have a dot jpg, that is usually for extension, and jpeg and png. Yeah, we have done with the selection file. So it will be returning a file dialog that will ask for image files. I think we need to have a name here. Yeah. So yeah, we have done this function, done with this function, and let me proceed with the next function. So here we done with this, and the main thing is this is the main function. For say I am saying it is a main function, but it is going to be another function. The main focus is here. We are going to display palette with this function. So def display palette of colors. So initially you need to use Matplotlib here. So we are defining figures and axes equal to plt dot subplots. So subplots in the sense we need to show 5 colors. So the 5 colors is going to be plots. So figure size is going to be 8,3. Yeah, we've done this line, and We can start a loop here just to enumerate the colors. I comma RGB R comma G comma B. So this is going to be the four variables. I is the iterator. Other three are the color codes, that is red, green, and blue. And we are going to enumerate it with the colors iterator. And hereby we are adding the patch. That is patch in the sense you are going to add three or more subplots. Dot add patch. plt.rectangle. So the main function definition is you are going to draw rectangles. That is, you are going to take different types of rectangles and you are going to use KMeans to get the main colors. That is the color palette there. So we are going to draw the rectangle here. plt.rectangle of I comma 0 and 1 comma 1 followed by the color pixels, that is RGB with 255 as a color code, equal to within the square brackets mentioning the RGB color. So R255 comma G slash 255, the same for B 255. Let me start with the brackets. Followed by the text for the color codes, ax.text I plus 0.5, that is the height, what height the text should be displayed. 0.5 I plus 0.5, then 0.5, and we are using a formatting option here, F R comma the same thing G comma B, and the axis should be center, that is horizontal and vertical, that is going to be center here. So alignment equal to center comma VA is going to be center. After VA center, we need to add colors. So color equal to white. So the white will be a more visible one for different colors. Let me then sometimes the white will not visible in some colors, so for that we need to give a condition like if, I'm sorry, I left comma, if r plus g plus b, r plus d plus g is divided by 3, so this is going to be one color, like less than 128, that is the threshold ratio. Else you are going to use black. So the thing is, once the area where white is not visible, black is going to be visible, vice versa. So let me give it like black, and the font size followed by is going to be 9. Let me have it like this, and followed by we have done with the main function and logic, and let me have like this. We have finished the logic and we have yet to show the plot. For it, ax dot set x limit and y limit. X limit of 0 to up to the length of colors. So length of colors is at the end of the day, it is going to be 5 fully. So len of colors, sorry, and followed by axis ax dot set axis, and this will set the function, set the axis with the function, and it is going to be a tight layout, that is all the 5 colors will be arranged in this same graph, that is plot. Plt dot tight layout, and followed by plt dot show. As we have done with all the functions, we can start with the main function. If, let me start the constructor, if name equals main, followed by the image path. So image path will be given by the main function equal to system dot rv. So you can now assume that why we use system function or the system library. Rv of 1, if len of sys dot rv is less than 1, that is there is nothing, please select next file, else select file function will be called again. I'm sorry. And the next line, if system dot so there is a negative case where there is no image path, like no image in the given path. So for this, if not image path you need to inform the system to exit the source code, that is the runnable code. Sys.exit. Yes, we have done with it, and followed by the num colors. So you need to declare all the everythings within the constructor which we have used in the other function. Num colors is equal to int of sys dot argv of 2, and again the condition. So if system dot argv is of 2, let me have this condition in the next section, and initially we can just give it like the arguments will be get from the, like all the arguments, that is 1 2 3 4 5, all the things are going to be colors. So that is the difference between the system argument and the colors. So here after this it will be int if length of sys dot argv is less than 2 or else 5. Then the palette. So palette is equal equal to it is going to extract the colors using the function which is extract colors. The image path we get it from the user while selection, and followed by the num colors. So the only thing that is being left is you need to display the extracted colors. Display palette of palette. Let me run this. I think that is being repeated now. So it is being running now. Let me wait for some time. Yeah, it appears. So we are selecting the same image now. So we are getting the color palette of the image. So it is being normal to all the images. Yes, I think you learned something today. Let me meet you with the new topic tomorrow. Thank you.